Hi guys, thank you for coming. Today I'm going to tell you about our internal tool, about our design system, which has name Cosmos. But before, let me introduce myself. My name is Artem, and I am Android developer at Badu, and I am responsible for design system in our team. But if you don't know what Badu is dating app where you can meet and date with new people, and we are available on all platforms in Android, mobile web, iOS, desktop web, and you have reached millions of users now. And over the years, we developed more and more dating apps, for example, Bumble, Lumen, and Chappy. And since the summer, we finally became the Magic Club group. And to show how big we have more than 5 million people in more than 5 million users across all our products. And what I want to tell you today, so firstly, I want to tell you about why do we need design system, how we migrated to design system, and step by step I will tell you about our tooling, how we improved it, and finally I will show you how it helps us in our feature development process. But before start, I want to show that we have a big teams which are involved in UI development. We have more than 60 mobile engineers, more than 20 mobile web engineers, more than 20 designers, and we want to reuse our UI. And it's really impossible to reuse if you have only one library in each platform, because it's not only about one team. We have to contact and communicate with another team, with a team of designers, which have separate processes. And to efficiently communicate, we have to set up strong rules of guidelines. And we started to use design system as the set of these rules. And what is design system? Design system is on the bottom of it, it's a UI rules and patterns which describes your UI, your brands. And all of these UI rules are documented somewhere in wiki pages. We have probably generated documentation, but ideas should be documented. And each team, designers, Android, iOS, mobile web, desktop web, should have the same library which are full of this documentation. And of course, there should be set up processes which are keeping all this stuff in the sync. A lot of companies already have design system. I will be happy if you will find your company on the list. And we also have design system which has name of Cosmos. Our design system are based on atomic design. It's super interesting conception that all complex components which we have consist from more simple atoms. And let's take a look on other profile screen in our application, and let's take a look at Instagram section. In fact, it's not just Instagram section. We have a component in our design system which has name view profile block, and its component describes state. It has a header. It also has a content. In content we have scroll list with list of photos, but it's not a simple photo. Each photo can be in also different states, just photo, like I already said. It can be in loading state, it can show error. And for all of the states, we have separate component which has name user card, and it's responsible for these states. It also can be in different looks. And also we have button, which has icon. It also has typography element on, and all this component and others we have in our documentation, which is generated. So and we follow these principles in Android, in iOS, and in total we have more than 70 components. iOS team has these components, mobile web, and today I want to talk about Android. But before start, I want to show you a small graph. We introduced mobile up at 2009, but started migration to design system in 2018. And all 9 years we didn't have any rules how to create UI, and so we had many redesigns, and because of it we had a lot of legacy. And to show which problem we had, I want to show how we worked. Imagine we received this design. We used simply, it's a tool, web tool, which connected to sketch file, and you can just see what designers send to you. And for example, you want to implement this text style. Developers see, oh, it should be P2, it has name, but in our code base it was impossible to find. We have our own naming convention. Okay, it's not a problem because it has a text size. Okay, let's try to find it by text size. And yes, it was really mess. We didn't support custom fonts, and because of it, we had different sizes. And for new joiners, it was really mess. So we had to understand which text style we had to pick. And we had many challenges which we had to solve. And in 0 stage, we had to solve all this stuff. And in theory, we wanted to see that designers just send to us list of mapping how to migrate from old styles to new ones, because we already used probably the same styles, but with different names. But in fact, it was like this, because I already shown you, we had different sizes. It was not only for text, it was the same for buttons and other simple components. And yeah, we had to refactor it, and when we refactored it, we introduced small, simple components like text, buttons, but we had to support the main idea of our design system. It's atomicity. And if we take a look on screens of our application, you can find that all of them has same components, but also they have same layouting patterns. In fact, we have a CT box component, which just placeholder for 5 components from our design system with fixed margin between each others. And if we take a look on other screen in our apps, we can find many and many screens which are following this pattern. And we wanted to support it. We wanted to support it in a convenient way. But to support it, we had to improve a little bit our tooling. And what we did for each component in our design system, we defined a model, immutable model, which describes its state. For example, for text component, in model, we will have a text, text style, text color, and probably other properties. How it looks like in our code base, and how we work with it. So text component, it's an element in our Android framework, should implement the bind method, where he consumes this model. We create the model with whole properties, and to show full text, we just call bind on it. And if you want to change text, we again create the same model, but with different text, and pass it to text component, and we will have it on the screen. But what about layouts? For layouts, we have more complex models, where in properties we have the component models, which are already connected to components from our design system. And layouts also have bind method, and for each field of model, we just dynamically inflate component from our design system. It's more complex. It's not just to show something. We have to dynamically inflate it. And to inflate it, we introduced small utility class, component controller, with just a class which has a link to component. And controller also consume component model. And how it looks, he just consume model. He asks to component, hey guy, do you support this type of model? And if component A answer yes, I'm supporting. So in this case, component controller just call bind on component A. And it's here the same like if I just call bind on component. But if component A answer no, I don't support it. In this case, controller removes a component from view hierarchy and try to find component who supports this type of model. For example, it can be component B, but component controller are keeping layout params for component and pass this type of model, this instance of model to component B. In this case, we just removed all components who doesn't support type of model and inflate who supports and pass it to it. And we have utility class which just always says, no, I don't support any type of model. I want to be removed. And yeah, it removed in the first passing any type of model. And we're using this type of model, the type of component to layout views. For example, if we return back to CTA box, in fact, it's just a XML file where we have 5 component views tabs for each slots. But here we define some layout params, can set margin. If it can be constraint layout, we set up here constraints. And how it works, if you want to show this screen, so we create a complex CTA box model, pass it to CTA box component. For each slot, component views tab will be removed and inflated a proper component from our design system. But to remind you, CTA box has only a bind method. And it can be a problem because imagine we have to create whole model in the same time. To probably some images we can receive from one source, text from another source, but we have to pass it in the same moment to show whole CTA box. And MVI architecture helps us to solve this problem. And ideas here is quite interesting that view are stateless. It can just emit intent. For example, you pressed button, it emit intent, that button was pressed. And we have some logic classes which are reacted to this intent and emit model with whole state of the screen or of the part of the screen. And we are using MVI core, our library for MVI. And how it looks like, view accepted view model with whole state, with whole properties, and just we map view model to our component models. But here we have a problem that always, after any intent, method accept from in view will be called. In this case, all this class, all this model will be created again and passed to view. And to don't waste performance, we always have to, in each view, check if the field is the same, like previous one. We don't have to apply any changes. And it should be done in all components. And we wanted to fix it, improve it globally. And what we did, instead of just bind method, we also implement setup method, which in where we register for each field in model, we register how we want to, which lambda will be triggered when this field will be changed. And if this field is nullable, we also created like onUpdate method, which will be called when field is changed, and onClear when we pass null, because we had a problem that developers forget to clear state when we pass null. And how it works when something changed, probably in this case header was changed, we just receive accept method. In this accept method we create whole model, but only lambda related to text will be called. And it implements super easily. We have model watcher, in where we have just three main properties: accessor, which is responsible for which field we are watching, diff strategy. We can define strategy, for example, we want to compare by value, by reference, or can pass another custom diff strategy, and callback, which will be called when this property will be changed. And each on-change method is just syntax trigger, where we register all these vouchers and watch for each field. It is also part of our MVI library. And when we define the framework, we define a smart diff algorithm, so we could just easily to migrate in all our components, and because they are reusable, it means that you need just only one time implement this smart diff algorithm, and where the component will be reused, automatically this part of UI will be updated smartly. But we had one more problem. We wanted to implement more and more components, but I already said in Badu we didn't have dedicated UI team for it. And for example, if developer will receive the screen and he wants to implement it from scratch, imagine we don't have any components. Here it's not just a two-image view, it's just a brick, a component from our design system, which are super complex. It can be like image with badge. Also, it can have halo. It can have badge with icon. It can be also with rounded corners, many different states. And if developer will implement this screen, follow all documentation, it will cost a lot for him. And we have old way when we just use images view, and it's like much easier. And the question is why we have to spend a lot of time here, and it was really difficult to sell this idea that we have to create a component from scratch with whole functionality. But from another side, what we can do, we just can easily create functionality what we really need in this case. For example, for the same brick, we can create just state where it supports only two images, image and badge, and it's much faster. And it also help us to create new components, because guys created components with functionality which he needed, and other guys already saw that components exist, and he just added new functionality, and it helped us to reuse components. But we have another problem here, that because of components are always modified, we had a huge risk to break something, because components are modified oftenly, it is used everywhere, and we also wanted to solve it, and to solve it, we introduced visual regression testing. The idea is quite simple. Remember, this guy just implemented this view, this brick component with two states, or with the state with two images, and he generated baseline, so how for his view. And imagine another guy probably in 1 month want to support another state of this component with this outline, and he implemented it and want to check, is it okay? Did he break something or no? He ran the same test, and after it, we want to compare and see that components are a little bit broken, and this guy has to fix this issue. And since the moment when we introduced visual regression testing, we were sure that all our old components are already in the same status like they created. We didn't break anything. And their amazing tool from Facebook, they introduced screenshot test library, which are based on UI integration test. They just receive view, try to emulate layout, measure, and draw method, and after it as a result it receives bitmap, and you can compare it. But imagine in this case we can introduce one more complexity, because the developer has to implement test, and he has also implement a view, but we can reuse code base for test and for view. What we did, we created small framework where a developer just, when he implemented view, he registered factory for view, how it will be created, and also he implements some decoration, how view will be changed. And here we can register many and many these decorations. And this decoration and factory will be parsed. And as a result, we will have gallery library with all our views, which developers can see. All views with different state. And on top of it, the same with decoration and factories will be called. And after it, we will have visual snapshot, visual regression testing. So here, like I shown, the screenshots are the same. And the idea is that developers do only one thing, describe lambdas, and automatically we will have a gallery and snapshot testing for it. And it really helped us to increase the amount of components in our code base. But we wanted to solve another problem. It is consistency. Let's take a look on button and try to find parameters in button. Button can have corner radius. It also can have text, which has text size, text font, line height, and it can have icon, which specific size. In total, we have at least 5 parameters. But since the moment when we use the same design system in Android, iOS, mobile web, all these parameters will be hard-coded locally. For example, in Android, we have XML file with these parameters. And imagine if designers wanted to just ask, let's change corner radius, and we have to do it on all platforms. Or probably they just forget to ask us, and somehow in their libraries will update it, and in this case we will have bugs, and probably iOS will update this corner radius, we don't, and we can face with some problems because of it. And the same thing for assets. In our code base we had many interesting assets which looked like the same. We had duplicate for PNGs and vector drawables. We had quite different files with assets which looks like the same, but in fact it was different files, and we even have had the same vector drawables but with different names. In our code base it was different assets. And in the same moment, when we started to think about it, in product management team and design team, they wanted to update visual identity of our app. They wanted to change text styles. They also wanted to change text colors. And they also wanted to change icons. And of course, we can do it manually, just in these files in Android, iOS, mobile web, update values, refactor icons. But next redesign will cost the same efforts. We have to do the same. But what we can do here is we just can somehow store all icons, all UI configs somewhere, and parse these icons and configs for each, and consume these assets in each platform, Android, iOS, mobile web. That is, the storage of these configs will be the same and single. And we decided to go with this way to improve our tooling, but in future the redesign will cost 0. We just update in single storage all assets and config. And in few redesign system, they have tokens. It's like a UI config. So if we return back to example with button, we can just have all these key values in JSON file. Why not? And parse this JSON file to receive it in specific for each platform format. For example, in Android, we could receive it in XML file, like our usual resources. And after it, when developer will implement new component, what he will do, he don't just check API of the component in documentation and look at designs. He also has to use these tokens. And still the moment that tokens we are receiving from like single storage, it means that component will be synchronized. If designers want to update corner radius, they just ask us to let's update it in global config and send this config again to each platform, and immediately, without any developer works, button will be updated. And we did it. So for this config, we use Amazon library, which where we can easily describe your UI, and it generate for each platform configs. For Android, we receive XML files, and yeah, the link of article where we describe it step by step. In Android, we have Gradle plugin, which we run and just download this XML file. And for example, how we use it, this is our text component. We use here tokens, which we are receiving from this pipeline. But what about icons? In theory, the problem absolutely the same. We can store all icons in some place and do the same job. So, in this place for us, it's sketch file. Designers are preparing for each brand sketch file with icons, and what we do, we just parse the sketch file. In first iteration, we are parsing it for intermediate format. After it, from intermediate format, we parse it to specific for each platform format. For example, in Android, we are receiving vector drawable, and how it looks like, it's default vector drawable file. But important thing that here we have a link to color, which are also already based on tokens. So it's mean if designers want to just update color, we will again run the script, and we receive new configs. And in this case, because it's vector drawable supports links to color resources, color will be changed in icon. We don't need even run script for icon. And we also have an article about it. So how we parse text sketch file. If you're interested in it, you can read and do the same thing. And if we are returning back to redesign issues, so what we did, we just connected our UI components to tokens, a little bit refactor old assets, run the script, and voila, we have a new redesigned app. And I want to share a reviews with small interesting tip which help us to solve small problem. In old design, we had the things when one color in one place in old design was the same, but in new app, the same color looked differently. For example, this red color here in new design looked like Carol, but the same red card in old app looked like a pink. And so here we have not just the updation config, we have like branching logic. Somehow, depends on screen, we have to smartly update this color. And how it can be easily solved? It can be solved easily if you will have a palette of base colors which doesn't have information about any context of usage of specific color, and one more palette with feature colors which has information about context where it will be used. And here it is not just a red card, it has a color feature like to you. And the same thing for this screen, it's not a red card, it has a feature live. And in configs and tokens we have a mapping how like to you color changed, how feature live color changed. And when we map our colors to feature colors, when we refactor a little bit, so we just run the script and the problem with design solved, and we easily solve it. And because of it, because of tokens, because of remote asset pipeline, we solved our consistency problem, because all constants, all assets now are located in single storage, and we just run script if we need it. And the same thing for all platforms. And small thing that if designers want again to implement redesign task, we do the same stuff. I mean, we just ask them, oh, let's update tokens and assets. We run the script, and it will be in 1 day solved. And the next stage was scaling. On the beginning of my talk, I say that we are Magic Lab. We have many different apps. We have a Badoo, Bumble, Chappy, Lumen, and they are completely different apps. But if you take a look on these two pictures, we can find that we have navigation bar in both of them. We have icon also in both of them. We have typography elements on both of them. And in fact, what we had design system in Badoo with documentation, with setup processes, with tokens, icons, and we had libraries, component libraries in different brands, and it's not synchronized. In Android and iOS it were different. And what we started to do, we started to just unify components and merge these libraries with our design system. And how we did it? We did it using these tokens. For example, if again we return back to button, so we can parameterize button by tokens and consume different set of tokens for these different brands, and the same button in code base will be looked differently in different apps. And because of we have atomic design system, in all places where this button will be used, it will be looked like it should be in specific brand. And more complex cases, if we return back a bit again for CTA box, we can also define not just only a corner radius, but we also define a gravity like this parameter. For example, in some brand it can be aligned, all children can be aligned to left. In another brand, all children can be centered. And again, because of atomic design system, if we put any component to this CTA box, depends on brand, depends on config, which are set up globally for application, content will be aligned to left or to center, depends on. And we supported it, so we can change it in runtime. And what happened after? Imagine if we increase amount of shared elements, what we can do? We can do the cross-app features when we just can create a module with layout, with single layout, and use here components from our design system and pass all configuration in app level. So depends on app, the same photo picker will look differently. And we have more interesting examples in chat. Chat are now integrating all our dating apps. So it's very complex component with different type of messages, and the idea is here the same. We just implement this type of messages in our library, parameterize them by tokens, and we are receiving different set of tokens, and depends on app, we see different results. And I want to mention about very important thing about the processes. I think it was impossible to implement all this stuff if we didn't set up processes. Like already said, it's communication between different teams. And we had syncs with iOS, Android designers. And super important thing, we introduced design operation role. So guy just review designs before we consume it in native apps. And the idea of this review is try to understand, is it already existed component? If so, he just mark it. And if no, he try to understand, can we little bit change it to reuse already existing, or we have to introduce new component. And we are receiving some kind of these screenshots where we see information about components. And it helps us to increase library of components, and also help us to unify components between different brands. And I think that's it. So what I want to highlight that it was super difficult journey. I shown you how it was before when we had like outdated set of styles, but step by step we improved our tooling, we improved our framework, we introduced tokens and remote assets pipeline, which helps us to keep all our UI identity in sync. And we improved our set processes, and it allows us to create cross-app features, which really imagine you just created one module, and depends on application you set up it. So it looks like adopted for specific brand, but you already have set of tests, and it's already tested. Thank you, guys, and you can find me near our stand. We have a stand with Badu, and also I wish you will visit Talk Jolt. He will talk about how we share business logic. I told you about how we reuse UI. And also you can find Arkady here. He implemented our RX multiplied from library, so feel free to ask. Thank you. And I think we have a time, and if you have any question, I will be happy to answer them.
Hi, great talk. Thanks a lot. Is any of this open source, or do you have any plans to open source it? Is there anything we can steal from you?
So, so what you can do, you can read the articles, and in articles I think we have open source algorithm how we parse something from sketch file, icon from sketch file. That's it. Other stuff is internal. But also you can use Facebook library for visual regression testing, which is like open source it. Thank you.